Hello, students. In this lesson, we'll discuss Mann-Whitney U-test. This is a non-parametric test, and this is a part of Unit 5. We have already discussed chi-square test before this. Now, we'll have a look at how to calculate Mann-Whitney U-test. So we can have two versions of this test. We can have it for small samples, which we call it as a small sample U-test, and which is like 10 or less than. So if it is 10 or less than 10, we'll go for small sample U-test. Otherwise, we'll go for the large sample U-test. So first have a look at small sample U-test. So what we have to do here, we have to calculate the U values for each of the sample. Sample 1, we call it U1. For sample 2, we call it U2. So it is like how you see Mann-Whitney U-test. It's like one alternative to the t-test. So t-test is recommended when you have two groups and the data which you are comparing, the variable which you are comparing, your dv, is measured on continuous scale. For example, you are measuring weight of male and female, and you want to see whether there's a significant difference between two. You can go for t-test. However, t-test also requires us have some conditions, like the data should be normally distributed and sample should be taken from random, and the nature of the data should be ratio. So if you do not meet these situations, these conditions, you can apply Mann-Whitney U-test for testing the difference between two groups. So Mann-Whitney U-test will apply for the ranking data. Number one, if you have ranking data, you do not have ratio data, it will work. Other thing, if the distribution condition is not met, sometimes normality is an important condition for doing tests. Mann-Whitney test, okay, will work with when data is not normal. So value of U1 is calculated as using this formula. So N1, N2 are the sample sizes for sample 1, sample 2, and in these values we have just used N1 and N2. Here we have used R1. So similarly, a very identical formula to this one is this. Only difference is that we have used R2 and here we use N2. So what is R1 and R2? R1 is the sum of the ranks for sample 1. Sum of the ranks, and this is a very important thing, because in the whole test we are going to calculate the sum of the ranks, and we are calculating U1 as well as U2. So if you calculate U1, you can calculate U2 based on this formula. You need not to calculate again U2. So the first step is that wherever we will be given data, N1 and N2 are already, we can very easily see from the data. Only effort is required to calculate R1 and R2. Let's move into the problem. So here we have one question, and the null hypothesis and alternate hypothesis are whether two populations are identical and whether two populations are not identical. Okay, so pause the video and read this question very carefully. I'm moving to the solution. So we have these data set. One data is from production department. Another data set is from marketing department. And here these values are the weekly compensation of the employees of the production and marketing departments. So you can count how many numbers we have: 1, 2, 3, 4, 5, 6, 7, 8. So we have N1, we can write as 8. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. N2 here we'll have as 9. So based on this formula, we have N1, N2. So we can calculate this portion very easily. For R1, we have to calculate the ranks. Now what we do, we arrange this data as well as this data. Both these figures, it means 8 plus 9, all these 17 observations, we have to arrange these observation in increasing order or decreasing order, one order, and then basically we arrange them in increasing order. First we have the smallest number from smallest to the largest, and then we assign ranks to these numbers. Okay, and after assigning the ranks, we again rearrange the data based on these classification. For example, we have arranged data for production department and marketing department, and then given them some range. Then again, these ranges, we should know the 5,000, what was the equivalent ranking of this number, what was the equivalent ranking of this number. So all the ranks we should know. Then we should add all the ranks from this one, this sample, we will call it R1, summation of all the ranks. And here we will also calculate the ranks. So let me show you how it has been done. So the rank has already been calculated here, see. So all the data we have combined, and for example 4800, this is group P. So this data has been reproduced in ascending order, increasing order, and then ranks are provided. Now what we do, we only calculate these ranks. Okay, so first we calculate rank for group 1, which is production P. Then we calculate the ranks for group M, which is marketing. So R1 is 1 plus 2. So this is production, this is production, this is production. So 1 plus 2 plus 3, and this is production, this is production, this. So these all values we have calculated, so we have added them together, and we call it R1. All the ranks for group 1, and you add them together, 57. Similarly, we do this thing for M. You start with this, then this, and this. All the 9 observations we have written here, and we have added them together, and summation is 96. Now we have to see which we have to calculate the U values, U1 and U2. U1 using the same formula as we have discussed in the previous slide. So you multiply N1 and N2, 8 into 9, then N1, N plus 1, 8 into 9, divided by 2, and then minus R1. You got the value as 51. Then you calculated the U2, which will give you value of 21. From U1 and U2, you have to pick the value which is smaller. Okay, that will be your final U value, and you make decision based on that. So you have to choose the smaller U value between U1 and U2. In the present case, we can see the smaller value is 21, and we have to choose this value. So we'll choose U2. So this is 21. Now how to make a decision based on this thing? For making a decision, we have to check whether U value is less than the critical value. It is quite contrary to what we have done earlier in earlier cases. So if U value is less than the critical U value, we are going to reject the H0. In previous cases, we have checked and rejected null hypothesis when the calculated value was greater than the critical value. But in Mann-Whitney U test, you will do otherwise. Your calculated value should be smaller than the critical value. Only then you reject the null hypothesis. So we have 21 as critical value. 21 as the calculated value. We have to check what is the critical value. So let's look at the table. So we have this Mann-Whitney table at alpha 1.001 and alpha 0.005. So here we'll look for the critical value of mann whitney U test. So we can see we have n1 and n2 as 8 and 9. So we choose one as 8 and another as 9. So 8 and 9, the combination will give you 7. You can choose any row or any column. For example, you can choose this as 9 and this thing as 8. It will be 7, by the way. So now what we have done, we have find out the critical value. So for sample size 9 and 8, the critical value is 7, and the decision we are going to make will be based on this. If our calculated value is smaller than the critical value, we'll reject the null hypothesis. In the present case, calculated value is not meeting this criteria. So 21 is not smaller than the critical value of 7. This is the critical value of u. So what we do, we cannot reject the null hypothesis, and we will conclude that these two populations are not different. So let me show you. So what we will conclude after doing this test, the two populations are not identical.